Hey guys, I wanted to work through some of this quiz from this morning here on chapter 16. So here on the first one, let me draw the reaction out. The carbocation's already given, so you know that this double bond reacts with the HBr in both of these cases. And you form this carbocation right here, which is already shown. So for the 1,2 product, the Br just comes along and attacks immediately right there in the 2 position. 1 position is always where that hydrogen added. So here's the product for that one. Like that. Now the more difficult of these two here are the thermodynamic one, because you have to go a bit further and analyze this. What is the most stable alkene that can result? And that's from the most substituted double bond. So if you look at my structure here, and let me do the resonance, that'll move over there like that. Oh, forgot to move it. That'll move over there like that, putting the charge right there. And you're comparing the number of alkyl groups here. Here we have 1, 2, and then 3 on that one. Here we have 1, 2, 3, 4 on this one. So the original structure here is tetra-substituted, which means that that's the most stable double bond. And so the double bond stays right there, and the products are the same for both of these. There's not a 1,4 product, in other words, because the double bond is more stable right here. But that's why I threw in another one. This one here is another thermodynamic problem. And this one here, it's going to be the typical one from the textbook. So that reacts like that. We form this carbocation, and you have to do the resonance. When you show the resonance on this one here, you see that this resonance structure is tri-substituted, whereas this one over here, the top one, is only mono substituted. So we want the most stable alkene for this one, and that is that. So then in the next step, the chlorine attacks that one, and there's the product. I did notice some people here deleted this carbon, directly attached the chlorine to the double bond, and couldn't count it correct because I couldn't tell where the double bond really was on that. Okay, the next one here is a chlorination. So with this, we have this mechanism. This is a symmetrical molecule, so it actually doesn't matter which one it reacts with here. But it will form the most stable carbocation, this one, which is tertiary, and then there's resonance like this. This is a kinetic one, so it doesn't actually matter if you analyze the resonance with that one. You do have to analyze it to form the most stable carbocation, but you don't have to analyze it to form the product. So with the kinetic, then you just add the chlorine. The next chlorine gets added to the 2 position. Here's a 1. Here's a 2 position. And you have to leave this double bond here. The other double bond stays. Okay. And then the next example is a thermodynamic example. Here, the most stable carbocation forms right here. Let me go ahead and show that. So it reacts with that. I actually showed the resonance structure of that. Okay, so there's the most stable carbocation, tertiary and secondary. And here's the resonance for that. And so this is thermodynamic. Again, most stable alkene has to form. Here you see that's tri-substituted. We got 1, 2, 3 alkyl groups. Over here we only have 2 alkyl groups, the 1 and the 2 right there. So this is going to be attacked by the bromine to form the product. It should look like that. Okay, see you Thursday.